A couple of days ago, a subscriber left a request in the comments section of one of my videos asking if I might demonstrate how to make kerfed linings. So I thought today I'd try and put that video together. And I'm going to start right out with materials. I don't think there's a lot of limitations on the materials that you can use to make these linings for a guitar, but I can say that I think of primary concern is workability. Um, a wood that will comply after it's been kerfed easily is nice. Something that will sand well is those are the big concerns. Beyond that, and of course that leads us to very low density hardwoods or conifers. Now, I've seen mahogany used, I've seen sapele used, western red cedar. I've used a certain amount of cedar in the past. I've used eastern white pine quite extensively. But over the last 12 years, 13 years or so, I use exclusively basswood, American linden. And I do that for a reason. I found out that basswood is quite acoustically dead. And when you make linings out of it, it helps reflect that kinetic energy back into the top of the instrument. It does not wick it down into the rim where it doesn't do us any real good. So that's become my first choice of lining materials for everything. Also, I do this rectangular cross-section lining, and I put a radius on the lower edge of it at my shaper. You could radius that any way you want. You could use something other than a radius, I suppose, whatever you come up with. And I guess if you really don't want to bother, you could just leave it rectangular. Might look a little odd, but you could do it. I don't anymore use the triangular cross-section linings. Now that doesn't mean that they're not worth doing, and it doesn't mean that you shouldn't. They're certainly workable. But I kerf my linings on the inside, and that way you see a smooth interior. With the triangular linings, you see the cuts, and there's nothing wrong with that either. Not a thing wrong with it. But I prefer the look of this rectangular lining. So you can do either one, and I'm going to try and show you a couple of tricks or two about how you can do both. Uh, the first thing that I want to do in fabrication is whatever material you're going to use, you're going to get a piece of this stuff. It doesn't need to be as large as this. I just happen to have large pieces of basswood. You want it obviously the minimum length of a piece of lining that you want to make. And by the way, this piece of lining is probably 20 inches long. You can do this, but it's not really worthwhile. Sometimes they'll snap off and they can get clumsy. Make them 14, 16 inches long. That's good enough. And at 14 to 16 inches long, two pieces will go around one side of the rim. It just makes things nice and convenient. At any rate, I'm going to start with a piece of board. The width doesn't matter. It's just that the wider you have it, the more slices you're going to get out of it for your lining. I want the board to be flat sawn, and I have a very good reason for that. I want this surface to be flat sawn, tangentially sawn, bastard sawn, whatever you want to call that. The reason being is that I'm going to rip 1/4-inch strips off the edge of that. I'm just going to keep cutting those off there. And when I do that, this will be the glue surface of my lining, the flat sawn surface. And over here will be the quartered surface. Now, quarter sawn or flat sawn doesn't mean too much at these narrow widths. However, if I have the quartered surface out here where the lining is going to bend, it's going to bend a little bit more predictably, because you may know that flat sawn material, the grain tends to overlap the way my hands are overlapped now. And as you bend that, in that little thin webbing that you leave in there, that may want to tend to snap. So a quartered surface, I think, will be more friendly for the work you're trying to do. The thickness I'm using is 5/8 of an inch. I'm sorry, I did not make metric conversions on that. Um, but I believe 5/8, if you convert that to a decimal figure, and then what is it, multiply that by 25.4, you'll come up with the metric measurement, something like that. Maybe I got that backwards. Anyway, uh, sorry for the math lesson. So the first thing I'm going to do now is cut strips off this. You can do this at your table saw. If you've got a real nice blade and you can get good clean edges when you rip, then you do that right there. If not, you can do this repeatedly on a bandsaw and you can drum sand those back to thickness. I'm not going to demonstrate all of that because it's not really about how to run your table saw or your bandsaw or your equipment really. But those are the methods that you could use. One thing is for certain, you need to have smooth surfaces because you need a glue surface on the lining and you want a clean surface. Excuse me, let's get the right thing. You want a nice smooth surface as a glue surface against the rim of the guitar, and you want the opposite surface to look nice and clean. That's all there is to it. So from here, I'm going to take you over to my drum sander and show you a gimmick that I've used in the past to make this triangular cross section. So I just finished ripping off a bunch of these 1/4 inch sticks, and just a reminder, the broad surface is my quartered surface, the narrow 1/4 inch wide part is the flat sawn surface. I made a bunch of those, and what I want to show you now is this device that I've used in the past to create this, excuse me, this triangular cross section. It's easy to do. Now you could rip these out directly. You could tilt your table saw blade, or you could make some kind of a jig and fix this stuff up. And I don't even know how I would do that. It seems like a pain in the rear end to me. The material is not that valuable, so I'm willing to grind part of it away to make this lining. And that's exactly what I do. I made this jig. This is just a flat piece of hardwood. Happens to be, it's an old piece of sycamore. And on top of it, I have fastened these little triangles that I ripped out. The angle of these triangles represents the angle that I want my finished lining to be. And I've lined them up here, and I just tacked them down with very fine brads on this stick, lining them up parallel. And at the opposite end of it, I pinned down this stop block because this stuff, when you run this through your drum sander, it's going to want to move away from it. It's going to want to, stream back out of it. So this little thing acts as a stop. And I just load a bunch of these in here. Try and do every other one. I think you could do every one. Doesn't really matter. But I just load those into the jig, and then I drum sand those off. And it will work those down beautifully. And it does it very quickly because you're really sanding such narrow width that you're not taxing your drum sander an awful lot. So you can progress through this very, very quickly. I will do just a very quick pass through so that you can see more or less how that works out. And there you can see the results. Now what I just showed you was a final pass, but this only amounted to like 3 passes with a drum sander. And you could do, whatever number you can fit in here. And you could make this thing as wide or narrow as you want it to be. I limit it to this width, probably based on the width of this board that I had. But if you get too many of these things, too many pieces in one of these, they can be sometimes a little difficult to control. So I kept it fairly narrow. But here's the results you get after just I think there was 3 passes, maybe 4 to get that. So really simple to do. Now let's turn our attention to the real problem involved in making this, and that is actually cutting those saw curves. Now I do all of my kerfing here at the bandsaw, my 14-inch saw, and I have a method for doing that that's fairly sophisticated, I guess. This is a sort of a slick exotic jig. You may have seen this in one of the other videos I did. But before I show you this one, I'm going to show you a real down and dirty method that I came up with, which I've actually seen other builders use before. If you don't want to go through the process of making a jig like this, or if you don't feel that you have the time, or maybe you don't feel that you have the skill, that's okay. There's other ways to do this. So I'm going to show you something simpler over here. What I did was mount this block. This is just a scrap piece of wood. It happens to be 5/8 by about 5 inches wide, I think. Um, I have it clamped to the bandsaw now, but before I clamped it down, you can see here that I cut a kerf in that with the bandsaw, only deep enough so that you've got more depth than the saw requires, obviously, just giving yourself working room. And I turned it around and moved that block forward back into the blade, only a few hundredths of an inch, so to speak, because that's going to serve my purpose. When the lining moves up to that bandsaw and gets cut, that block of wood is going to stop it, leaving a web out here. Now, I hope I didn't have the camera too close. Can you see that a little better? The block acts as a stop, and when my lining material moves in, it's going to stop just before it cuts all the way through the work. This is simple to do. It can be a pain to set it up, but it's pretty simple. And if you don't have a lot of fancy jigs and things, this can be a way that you can make yourself some linings really easily. Now my guide is way up out of the way just for purposes of filming. I'm going to move that down in the next segment, and I'm going to show you how this thing works. Now to set this up to actually get it to perform, you're going to want to take a piece of scrap material, or I'm sorry, not scrap, but a piece of your lining material. And you're going to want to make some test cuts, because you have to move this block back and forth until you have it in the correct position so that you leave just that little thin web, which turns out to be only about 9 or 10 thousandths of an inch. And that's very difficult to measure with such a small object. So you have to kind of feel your way around. What I found handy is if you have a leather mallet, you could use a wood mallet or even a hammer. You can to move this back and forth, and I'm not going to do it because I have it adjusted. But by tapping this with a leather mallet or something back and forth, you can get it where you want it. You want to try and make this edge right here, this leading edge, make that square with your miter gauge slot. That's also going to help you because it'll help keep those cuts square across here. Now, I also figured, well, we need a way to index this, and usually those cuts want to be about every 1/4 of an inch. They could be a little less, a little more, depending on your preference, I guess. But what I did was I made a first cut. I took a block, another scrap block here. Can you see that okay? I took this scrap block, I just double-faced taped it to my miter gauge, and I moved it into the jig and made that initial cut, and then made a mark a 1/4 of an inch away from it right here and squared that off. And by having this only 5/8 of an inch tall, or even a little less, I can see that mark real well, and I can line up the previous kerf with it and cut again. Now, this is admittedly a little bit slower, but it still goes pretty quick, and these kerfs do not have to be precise within thousandths of an inch at all. In fact, I believe I've seen a short video of a builder in, I think, South America, who set up a similar device and cut these by eye because he was fully aware that they don't need to be absolutely perfect. So I'm going to show you how this thing works. And I brought my guide back down, keep ourselves safe. And you see I'm just lining the previous cut up with the mark, I cut, and just keep doing that. And if your kerf is, if that web that's still left, if that's too thin, then make an adjustment. If it's too thick, make an adjustment. But it's really pretty simple to do. And you can make, by this method, you can make enough of this stuff for a guitar in, I don't know, probably 20, 30 minutes, maybe less, depending on how careful you want to be. I'm being fairly meticulous right now. But see, that works very well. This is a really, this is a very simple, no particular high-tech anything required method that you can use. Now, it's been my experience also. I want you to look at how wide those kerfs are. I'm using a 1/4-inch blade here. This is 6 teeth per inch. I am not in favor of that kerf being that wide. I think you're better off to use an 1/8-inch blade that cuts a little narrower kerf. That's my preference. It's not an absolute necessity. I just prefer that. And also, you get a little bit cleaner cut. Another thing that I wanted to show you, if I can find it, is here's a piece of lining, and I mentioned that I rounded these over at my shaper. And I didn't want to set that up. And it also occurred to me, what if somebody doesn't have a shaper, or what if they don't happen to have a router table? You can't run a router freehand over these little narrow sticks. It's hard to do. I took a block plane and set this up on the bench, and I just rounded that over by hand. Excuse me, by hand. And there's no reason why you can't. I haven't even sanded this. If I sand this with 150 grit, it'll be just as clean and smooth as can be, and it'll get rid of all of those little facets that are in there. But that's a way you can do that. And if you're going to do one guitar at a time, so you make enough for that guitar. If you want to spend more time, you run enough for 2 or 3 guitars while you're at it. It's just that easy. Now, this more sophisticated method that I have really only improves accuracy, or should I say consistency, and it's sort of fun to play around with. But the previous method is just as good. Um, this whole thing is based on a piece of plywood, a platen, if you will, which I screwed on the underside of it. I cut a dado in it, and then screwed a spline in there that rides in the miter slot gauge, so that I can adjust this back and forth and put it where I need to put it. And I also use that to cut, rip this with the bandsaw itself. And then I made this slider right here. This slider is held together by this upper beam, because it's cut nearly in half, as you can see. But that also rides on another groove, dado, if you will, that I cut in the upper side of this piece of plywood. And all of this, if you're going to make something like this, you want this edge, that groove, and that groove to all be parallel, therefore cut from exactly the same edge. So this spline allows this upper platen to ride back and forth. We'll get to the other stuff momentarily. This thing is put on the saw, and it's hooked on the table by means of these pieces of scrap metal. These were, I don't know, something out of a drafting table, I think. And I'm going to clamp this into position, because once I get it where I want it, I don't want it to go anywhere. I don't want any movement. So now what's going to happen is, as the jig moves forward, it will have the material in here. It will move forward and make the cut. And at the same time it does that, this beam out here is going to hit this stop, and it's going to move, causing this little pointer to advance 1/4 inch. And I'll show you this again from the other side. And it will move the lining stock 1/4 inch to my left each time I make a cut. And then back here is this threaded stop. I'm going to move you around and show you that from this angle. This threaded stop just allows for fine adjustment to keep this platen moving only as far as it needs to move and no further. So I'm going to set this up off camera and then go back through and show you how this thing works. So I've got the jig set up now on the bandsaw. And I will mention that this jig works just as well for this profile as it does the triangular profile. You would have to adjust this little registration device down here maybe, but other than that, you set it up for what you want to do with it. So it's really very simple. If I place my material in the jig, as I move forward with this, my registration device, as you can see, moves, and it causes this to advance that piece of wood 1/4 of an inch, or whatever I adjust into it. It's adjusted by this stop up here. It rotates on this pivot here. So a little bit of homework and some calculation as to how you advance this or how you control that is in order. But as you can see, this is really not rocket science at all. Now, I have this block over this pivoting arm. That's only to keep it down and to help keep this registration pin over here in the correct orientation. I have a spring for retraction so that it doesn't just move out and stay there. And I don't know if you can see it, but behind this block right here, I've just got a pin to keep that arm from being pulled back too far by the spring, because after a while it moves completely away from this stop out here. So nothing too difficult to do. I did put, I may have to move you a little bit, but I did put a bolt right here, uh, a slot in this thing, and a bolt with 2 nuts on it so that it's not down tight, so that this upper platen can't jump up and down either. And then this adjustment right here is simple to make. I did mine with a piece of metal, but you could do this any number of ways. Even if you did this with a piece of wood and threaded it, and then flood your threads with super glue, I'm sure they'd be durable enough. This screw and this little head out here is what stops this upper platen and limits its movement. Adjustment can be a little frustrating sometimes because this happens to be a 1/4 20 thread. Well, at 20 threads per inch, that means 1/4 of a turn is 12.5 thousandths of an inch. That's more than the thickness of the web that you want left. So adjustment can sometimes be a frustration. But once you get it adjusted, you pretty well got it made. So I'm going to change the position of the camera and bring you around right in back of this thing and show you what I do to operate it. The only disadvantage I have with this is once the material advances, I have to put a grip back on it so that when the pivot arm moves backwards, it doesn't drag the material with it. I suppose I should make this thing fully automated. There's a guy out there on YouTube years ago, I think his name is Mackenzie, that did one of these that's fully automated. It's quite an affair to watch. So I'm going to move you around and you can see how this thing is working. So I just place my material in here and it advances and I grab on with my right hand and pull back. And you just keep doing that and you can see that it advances nicely, consistently. And after a while you get into a rhythm with this and it just does the work for you. I even put an arm over here to catch a long piece and kind of pull it away from the column of the saw if I'm making really long sections. And there you go. I can whip out enough linings for 2 or 3 guitars once I get them cut. Once I get the sticks cut, I can whip these out enough for 3 or 4 guitars, probably in 20 minutes. Now there is another small disadvantage that I want to point out. with this particular blade. I did not change this blade for the demonstration, but you can see how rough those cuts are. Uh, I'm working quickly. If I wanted to spend a lot of time, I could eliminate a lot of that fuzz and that tearing. But with an 1/8 inch blade or even a 1/4 inch blade that's 10 teeth per inch, something like that, you can eliminate almost every bit of that. This is really, that's not acceptable. I'm going to have to find a way to clean that up, or I'm probably just going to discard that and not even try to use it, because I want a much smoother gluing surface inside. Well, there's about everything I know about making kerf linings for guitars. I do want to show you this one strip that was made with a proper blade, and you can see there's no tearing and that sort of thing. That's really important that that is smooth in there. Lastly, I want to say about these two devices. Um, if you're not a tool maker, a jig builder, that's all fine. And if you are a person who, like myself, will practically make jigs for the sake of making jigs, that's fine too. But the first method that I showed you is extremely low tech. You don't need a bunch of slick exotic tools and devices all the time to accomplish what you need, and to accomplish what you need to do really, really well with an awful lot of finesse. So keep that in mind. If you're new to guitar building, you guys and people that have been around this for quite a long time have done several. You already know this, I'm sure. But if you're just getting into this, I just want to repeat once more. Uh, don't get all caught up in a bunch of jigs and slick fixtures and tools and devices, because sometimes you just don't need them. And it's easy to get confused and think about what manufacturers would do. But we're not manufacturers, so we don't need to think along those lines. Anyway, sorry, going on and on. Shouldn't be doing that. Thanks an awful lot for watching. I'm Kevin Ledoux, the Pragmatic Luther. Hopefully have shown you a pragmatic method for making linings, reminding you that I am, in fact, the largest manufacturer of acoustic guitars in the entire town of Triangle, New York, and thanking you again for watching. See you next time.